Hi everyone, in this video I'm going to talk about interpretation and hypothesis testing of linear regression models. The topic is interpretation and hypothesis testing. Okay, and it's linear regression model. Okay, so we discussed a lot of regression model, linear regression analysis in our previous videos. So in this video, I'm gonna talk about the interpretations, right? So when you presented a result regression line, how to interpret it, and then how you're gonna do hypothesis testing on the values you see from a regression line. Okay, so let me start by putting out the model we're looking at is linear regression model with a single regressor. Okay, so now I'm introducing a term called regressor. Regressor is just your independent variable, which is, by convention, people call this x. Okay, so regressors. We put out the model, y equals to beta naught plus beta 1 x plus u. Okay, so y is again our dependent variable, and then beta naught is our intercept, and then beta 1 is our slope, x is our independent variable and also called regressor. Let me just do it this way, and u is our error term. So again, u are the values or things that we haven't included in our model yet, right? So as you can imagine, there are a lot more factors to explain why. So putting only one regressor or one independent variable here is not enough. So everything we did not include or we don't include in the model is captured in u. Okay. So this is the model that describes the relationship between x and y. But then again, we cannot get the whole population. We cannot get every single data points, every single person. So we have to use our data or use a sample to estimate. So the next step is use data to estimate the relationship. And therefore, some people write y hat equals to a plus bx, and then some people like to write y hat equals to beta naught hat minus beta 1 hat x, right? So they're both correct, right? It depends on how you want to do it. Okay. So the one thing that's important is, as we discussed in our previous videos, these equations can be used for prediction. Okay, or estimation. Okay, so now let's go ahead and talk about interpretations of these variables. So interpretation. Let's talk about a, right? A value or b not hat. So a is our intercept. So when do a show up, right? Or when a is the value for y hat, it's when x is equal to 0, right? So when x equals 0, this term drops out. So y hat equals to a. So a is intercept. The interpretation is the predicted value of y given the value of x is 0, right? So when the value of x is 0, your y hat equals to a, right? So a is the predicted value of y when the x value is 0. But sometimes the value makes sense, sometimes the value doesn't make sense. So let me just put a note that the value might not make sense, and you'll see why. And I'll do an example that when a gives you the value that doesn't make sense, okay? But that's the interpretation. The value of y hat when x equals 0. That's the prediction for A. B, right, so B here. Okay, so B is the slope. So the interpretation is the changes in the value of y given the value of x change by 1 unit, right? So when x change by 1 unit, how much, or the predicted change, right? Sorry, let me give this the predicted change, right? So if your value of x increased by 1 unit, how much, or what's the change in the value of y, the predicted value of y change, you will get, right? So that's the value of b, right? So x go up by 1, y hat go up by b, right? B might be positive, might be negative, but it's the change in the predicted value of y. Okay. So yeah, so up to this point, we get interpretations of interpretation of A and B. And let me quickly put a note here. Note. So usually, the value of x is continuous, but there are special cases, right? So let me give a special case. Special case is when the value of x is what we call a dummy variable or binary variable. What does it mean? It means that x value takes on two values only, 0 or 1. So that means x equals to 0 or x equals to 1, right? So yes or no. Right? So for example, male or female, right? So that's one example. And then smoker or non-smoker, right? Yes or no, right? So in that case, x takes on two values, 0 or 1. Okay, and we'll come back to this when we do an example. And then I want to talk about hypothesis testing in regression. Yeah, so hypothesis testing. So when you presented a regression result, you'll be presented something like this. Y hat goes to A plus B x. And then you'll be presented some values under, A and B. These are the standard error of A. And this is the standard error of B, right? So if you have the predicted value and you have the standard error, you can do hypothesis testing, okay? So we're interested in whether the effect of B is significant, right? So whether B has an effect or whether X has an effect on Y depends on B, right? So if B is 0, that means X has no effect on Y, okay? But it's when B is not 0, then X has effects on Y. So B is 0 or not is very important, and that's something that we're interested in. And some people also interested in testing the value of A, that's also important, but the main interest is most likely be on testing whether B is significant or whether X has effects on Y, and that's testing whether B is 0 or not, right? So if it's 0, no effects. If it's not 0, it does not matter whether it's positive or negative, it has effects on Y. that means so that basically means that if we write out the null hypothesis, H naught is when B equals to 0, or let me not use B here because I am testing the population value, the true value. So let me just say B1, beta 1 equals to 0. The null hypothesis is beta 1 not equals to 0. So has no effect. X has no effect on Y. X has effect on Y. Okay, that's what we're interested in. So test statistics. So test statistics equals to our B, our predicted value, minus, I'll say beta 1 under null hypothesis divided by the standard error of beta 1. Okay, and we're going to do z-test, right? Because our sample size is pretty big, right? So most of the time it's pretty big, and we are able to do the z-test. Okay, so let me pause and really think about this. So a lot of times we're testing whether X has an effect on Y, we're testing the value 0. So often this one is 0, but it does not have to be 0, right? Maybe we want to test whether the effect is 1, effect 2, right? So this one does not have to be 0. Okay. So yeah, but most of the time it's 0. Okay, cool. And then the decision is the same as before. Reject null hypothesis if the test statistics is greater than the critical value. Okay, so if the test statistic is greater than critical value, we reject the null hypothesis, just like before. So let me do an example, and using the example to combine what we just did, the interpretation, hypothesis testing. Okay, so example. So wage hat, right, predicted wage equals to minus 0.8.6 plus 0.78 education. Okay, and then the standard error is 0.76, 0.17. Okay, so these two are the predicted value, and these two are the standard errors. So what is the interpretation of say the value minus 0.86? What is the interpretation of this value? So as we discussed before, so this is the predicted wage of someone with 0, right? When X is 0, year of education, it's minus 0.86, right? Okay, but this value doesn't make sense because even though you have no education, you go out to work, you get money, right? You're not going to pay someone to work, So this does not make sense. So this value doesn't make sense. So this is a good example showing you it's possible to intercept does not make sense. Okay. So number 2, interpretation of 0.78. Okay, so what's the interpretation of that value? This is, say, 1 year, one more year of education, likely to increase wage by 0.78, right? So that's the interpretation. If education plus 1, then wage is going to go up by 0.78 units, right? getting one more year of education increase your wage by 0.78. Okay. So number 3, what is the predicted value or predicted wage for a person with 6 years of education? Okay, so with 6 years of education, so this one is a prediction question, right? So if you plug in 6 here, you get its predicted value, right? So basically, just plug in 6 in the equation. Wage equals to minus 0.86 plus 0.78 times 6. This equals to minus 0.86 plus 4.68 equals to 3.82. So this is the predicted value. So this is a prediction question that I think it's very likely to show up on the test. You know. Yeah. Okay. That's number 3, and then number 4. Let's do some hypothesis testing. So 4, say, are the coefficients statistically significant? Okay, so are the coefficients statistically significant, right? So the coefficients, you know, here I want to do 2. You know, I want to do of A and B. So let's see, let's do A first. Right? So null hypothesis, you know, beta naught, right? We're doing A equals 0. Beta naught equals to 0. And then our test statistics equals to minus 0.86, right? That's A minus the value I'm testing on, 0, divided by standard error 0.76, and that's equals to minus 1.132. And let's do take the absolute value. So yeah, let me do alpha equals to 5%, and we're doing 2-sided. Okay, and absolute value minus 1.132 is less than 1.96, and we fail to reject the null. Fail to reject the null. That means null is it's likely to be true. So our A is not statistically significant. Right? In order to be statistically significant means that A is likely to be not 0. So in this case, because the null is true, well, not saying that null is true, just that we fail to reject the null, that means the null is likely to be true, not saying it's true, likely to be true, then A is not statistically significant. Okay. Let's look at B. Okay, so we're looking at so this one is the intercept. Let's focus on the slope. So the null hypothesis, this one we're doing the slope. The null hypothesis, beta 1 equals to 0. The alternative is beta 1 not equals to 0. And our test statistic equals to 0.78 minus 0 divided by 0.17. The standard error equals to 4.588. Okay, and then 4.588 in absolute value is greater than 1.96, and that means we're going to reject the null. Reject the null. So the alternative is likely to be true. So beta 1 is likely to be not 0. So beta 1 is statistically significant. And that means, so if beta 1 is not 0, that means education matters for wages. Okay, so wages, no, education has effect on wages. Okay, very good. And before we finish, I want to do an example on dummy variables. So when x value is only 0 or 1. Okay, so this example with dummy or binary variable. Okay, so let's say wage equals to 768 plus 625 times the variable for male. So male is a variable that male equals to 1 if your sample is a male. Male equals to 0 when your sample is a female. So it's a dummy variable or binary variable. So the question for the purpose of this course is, can you understand or can you interpret the value 768 and the value of 625? So the way we do this is say set, right? Let me set male equals to 0, right? If we set male equals 0, your wage hat equals to 768. So in this case, we get 768 for male equals 0. But when is male equal to 0? Male equal to 0 means it's for female, right? So that means the interpretation of 768 is the average wage for a female, right? That's it. And then what is the interpretation of 625? So to get 625, we need to set the variable male equals to 1, and that's representing male. And when male equals to 1, the variable male equals to 1, the wage hat goes to 768 plus 625. Okay, so this 768 is the average wage for female. Then what's this? So this 625 means that if you are male, your wage, your average wage is this amount higher than female. So the interpretation of 625 is on average, male's wage is 625 higher than female's wage. Okay, and that's the interpretation, right? So with this example, you see that on average, the female's wage is 768, and on average, male's wage is 625 higher than female's wage. Okay, very good. So this is an example for dummy variable or binary variables. Okay, very good. So I think here's where I want to stop this video. Thank you for watching. I'll see you in this video.